Let's say we had the chemical reaction sodium plus chlorine gives us sodium chloride. And I would have to balance this. And I say that you have to make sodium chloride. And we're going to start with, I give you a beaker, and it's filled with 3 moles of sodium. And now I ask you, how much sodium chloride can we make with this 3 moles of sodium? So 3 moles of sodium, how many moles of sodium chloride can be made? How many moles of sodium chloride can be made? So this is how we're going to use our molar ratios. Think of this as a conversion problem. We have to go from moles of sodium to moles of sodium chloride. So the first step, as always, is put the given over 1. So I'm given 3 moles of sodium. And that's going to go over 1 times a new fraction, old unit on the bottom, so moles sodium. And what are we looking for? We're looking for moles of sodium chloride. Now, before, when we did two-step conversions, we had to make sure we were allowed to do this kind of conversion. Do we know a relationship between moles of sodium and moles of sodium chloride? Well, it turns out we do. Whenever we have moles and moles in a fraction, the relationship is the molar ratio found in the balanced chemical equation, or BCE for short. So whenever we have moles and moles, we can convert. And the way we're going to do this is we look at our balanced chemical equation, and we see that the number with sodium chloride is 2. So that's going to be the number that goes here. And the number with sodium is a 2. So we're going to put that on the bottom, because this reaction says 2 moles of sodium react to give us 2 moles of sodium chloride. In this case, they happen to be the same. So we check our units, moles sodium cancel, we do out our math, and we end up with 3 moles of sodium chloride. So it's the same stoichiometry we've been doing before, just with a new conversion. We have to go moles to moles, and when we have moles and moles, we use a molar ratio, which can be found in the balanced chemical equation. Now let's try another one. Now we have the reaction between calcium and nitrogen to give us calcium nitride. This time I'm going to ask you to make 4 moles of calcium nitride. How many moles of calcium are needed. So I want you to make 4 moles of calcium nitride. How many moles of calcium are needed? We're going to approach this the exact same way. We take our given, put it over 1, 4 moles calcium. Actually, calcium nitride is our given. Times old unit on the bottom, moles calcium nitride. And on top, our new unit, because we can convert moles and moles, we can go directly to moles of calcium. The relationship, when we have moles and moles, we look at our balance equation, and we see that calcium has a 3 in front, and calcium nitride has a 1. So now we can multiply, do our math out, and we end up with 12 moles of calcium are needed. So in order to make 4 moles of calcium nitride, we need 12 moles of calcium to start. Now let's say I am burning propane, C3H8, and I want to know how many grams of carbon dioxide are produced when I burn a certain amount of propane. So the amount of propane that I have in my tank is 56 grams of propane. So we talked about how to go from moles to moles, but now that I'm giving grams, what do I do? Well, let's go back to that chart we looked at originally when we were doing conversions. This chart showed us how we can convert from one unit to another, and we always had to go through the mole. Now we're going to add one more thing, and just like we said the mole is a bridge between units, the mole is also a bridge between compounds. So what we can actually do is convert from the mole back to the mole for different compounds, and that's what we did on the previous page. So we went from the mole back to the mole, but we changed compounds. So we can convert from one compound to another using the molar ratio, the balanced chemical equation. This is the only type of conversion that lets us switch compounds. So in this problem, where I asked you to go from grams of propane to grams of carbon dioxide, what we're actually going to have to do is go from the gram to the mole, convert from moles of propane to moles of carbon dioxide, and then convert back out to grams. So how does this work? Well, it's identical to all of the stoichiometry we've done so far. So first, given over 1, 56 grams of propane over 1. We then have to convert, but we can't convert to carbon dioxide. Remember, carbon dioxide is our goal, from grams. So in our next fraction, we'll have grams of propane on the bottom, and on top, we're actually going to convert to moles of C3H8. So we didn't change our compound. It's still propane, C3H8. Now we need a new fraction. And in this new fraction, old unit on the bottom, so moles of C3H8, and we can convert now to moles of CO2. This is that molar ratio. And in the last step, we convert from moles of CO2 to grams of CO2. Now this seems like a long process, but it's really pretty straightforward. Our given is in grams, so we're starting here on the chart. In order to get to carbon dioxide, we have to get to moles. So we go grams to moles, which is this fraction. We then convert moles back to moles in order to switch compounds. So we go moles of propane to moles of carbon dioxide. And then finally, we have to go from moles carbon dioxide up to grams of carbon dioxide. Now we just plug in the numbers. So we have 1 mole of C3H8 is 44 grams. That's the molar mass. We know that the ratio of propane to carbon dioxide is 1 propane gives us 3 moles of carbon dioxide. And then we know that 1 mole of carbon dioxide has a mass of actually 44 grams as well. Carbon dioxide happens to have the same mass as propane. So we have all our numbers in. Now we're going to solve, and we end up with 168 grams of carbon dioxide. So now we know that when 56 grams of propane react with oxygen, we get 168 grams total of carbon dioxide. And I just want to point out one more time that this was a coincidence that the molar masses were the same. They usually are not. So this just happened to end up being the same thing, but these are usually very different numbers. The last thing I want to point out is that we can use this method to solve for any given value. What I mean by that is maybe instead of grams, I'm given liters of a gas, and I need to know how many liters or grams I get out. So all you have to do is convert from liters of gas to moles, convert to moles of your new compound, and then convert back out to either grams or liters or particles depending on what the problem is looking for. So just remember, convert to moles, switch your compound, convert back out.